Hello everyone, my name is Ayush and we are solving the third problem of the Shastra Challenge 3 Contest A, that is Maximum Fruits 1. The problem states that you are at a fruit store having n fruits. There are m buyers coming having some amount of money which is given in the array money. There is another array fruits which denotes the prices of the fruits. Each and every buyer wants maximum amount of fruits with the money they have. Try helping them by returning the amount of fruits each buyer can buy. The input format is the first line is the test cases denoting the number of test cases. Each test case is contained of multiple lines of inputs. The length of the array fruits is given by n and the length of money array money is given by m. The constraints are test cases is between 1 to 10 to the power 4, n is smaller than 1 and m should be smaller than equal to 2 into 10 to the power 5. The output should be we have to return the amount of fruits that can be bought by each buyer. Now let us understand the test cases of this problem. Now, with the help of the test case given here, let us understand the approach of the problem. So, in the first test case, it is given 5 and 4. 5 is the size of the array which have the fruits, and 4 is the size of the array which says about the amount of money that the buyer has. Now we have to find the maximum fruit we can buy with the help of the money we had. Suppose we have 2 rupees, so we can buy the fruit of 2 rupees only. Now if we have 3 rupees, so we can buy the fruit of 2 rupees and 3 rupees, either 2 rupees or 3 rupees. If we have 5 rupees, if the buyer have 5 rupees, he can buy the fruit of 2 rupees, 3 rupees, 4 rupees, 5 rupees. And as the problem states that we have to find the maximum fruit we have to take in our bucket. So we can take the fruit of 2 rupees and 3 rupees both, so that we can take 2 fruits in 5 rupees. Suppose we have 10 rupees, so we can take 2, 3, 4, 5 and 6. But for maximum, we can take the fruit of 2 rupees, 3 rupees and 4 rupees. We can take 3 fruits. The sum of this all comes out to be 9 rupees, which is smaller or smaller than 10. So the buyer can buy that fruit. Okay, so what is the approach, what the pattern that we can find in this problem? That if the buyer have 2 rupees, we can find only one fruit of 2 rupees. If the buyer have 3 rupees, we can find the either 2 rupees or 3 rupees fruit. If the buyer have 5 rupees, so we have to take the summation of both this, summation of 2 rupees and 3 rupees, and it comes out to be 5 rupees. And for 10 rupees, we have to take the summation of the 2 rupees, 3 rupees and 4 rupees, which comes out to be 9 rupees, which is smaller than or equal to, which is smaller than 10. So let us see the code of this problem. We are taking the target value of the money, the target, that this is the target amount that the buyer has. For summation of the prices of the fruits, we are taking sum equal to 0, and for storing a value, we are taking answer equal to 0. First for loop is for the number of the amount of money that the buyer has. And the second for loop is for the fruits. It's starting from 0 to n, and we are taking the summation, and we are checking what is the condition, that the target value should be greater than. It means the summation should be smaller than or equal to the target value. Then we have to take the fruits, but we are applying the condition that if the summation is greater than target value, then we can break the condition, and that answers comes out to be our output. Okay, so by this approach, this brute force approach, we can say that two for loops are applied on this. In this, two for loops are taking place. So the time complexity comes out to be O of n square. Time complexity comes out to be O of n square. So can we optimize this? Can we optimize this solution? Yes, we can optimize this solution by another approach, the binary search approach. So now we have to see what is the binary search approach. In the earlier brute force approach, what we were doing, that we were taking the summation of all the elements, summation of all the prices of the fruits, and we were comparing with the amount that the buyer has. So in this approach, in the binary search approach, we are initially only taking the prefix sum of every element. I mean that, how to take the prefix sum? First element starts from 0, so 0 plus 2 2, and then 2 plus 3 5, 5 plus 4 9, uh, 9 plus 5 14, and 14 plus 6 20. I had created the prefix sum of this element. Now I just have to compare with the target element, that if the buyer have that much money of the prefix sum, then he can buy the number of fruits or he cannot buy. So now let's see. The two can, just a second. First buyer have 2 rupees. So he can buy the fruit of 2 rupees. But he cannot buy the fruit which costs 5 rupees. So he have to return the index of 5 rupees. We can see by the sample output that this is the index 0, this is the index 1, and this goes on. So uh, so we can see that 2 is meeting the condition, but after 5 the buyer do not have that much money to buy the fruits for 5 rupees. So we have to uh, give the solution of that index. Now for 3 rupees, if he had 3 rupees, then also he cannot buy the fruit of 5 rupees. Then he have to return 1, the index of this 5 rupees. Now he have 5 rupees, so he can buy the fruit of 2 rupees and 5 rupees. So he can buy 2 fruits, and he cannot buy the fruit of 9 rupees. That's why I can give that uh, the index of this element, that is 2, 0, 1 and 2. After that 10 rupees. He can buy the fruit of 9 rupees but cannot buy the fruit of 14 rupees. That's why he can give the index of 14 rupees. Now let us see the binary search code, the code of this binary search approach. Now let us see the code of the binary search approach. First we have to initialize the test cases and take it the input of the test cases. Now we are running the test cases. We are, for taking the two arrays, we are taking two sizes, and we are taking two arrays for fruit arrays and money array. We are taking the input of the two arrays, and after that, what was the approach? We first have to, as we are applying the binary search approach, the main condition of the binary search is that we have to sort the array. So first we have sorted the array, because binary search only applied on the sorted array. So we have sorted the array. Then we had find the prefix sum of the full fruit table. Then we are applying the binary search to find the target value. So we are started the target with money, in the money array. and it has two pointers, the start pointer that starts from 0 and end pointer that starts from size -1, that is n minus 1. In this while loop is considering that we have start is smaller than equal to end. This is the algorithm of binary search. We have to find the middle element and we have to compare the middle element with the target. If we find the middle element as smaller than or equal to the target, then we will increase the value of start to mid +1, or else we will decrease the value of end to mid -1. And as we write the test as we do the test cases on pen paper, we find that the start value and the answer comes out to be same, so the cout can be written as the start value. Um, if we observe the binary search solution, we will find that we are usually finding the upper bound of the value. What is the upper bound? Suppose in an array, uh, if we found a target which is greater than uh, the buyer's amount, the first element which is greater than the buyer's amount, the very first element which we found which is greater than the buyer's amount is called as the upper bound of that element. So we are just finding the upper bound in the binary solution. So to optimize this binary solution code, we can use the STL of upper bound in C++, so that we can optimize the solution and make it more efficient. So what we do, we as earlier we are putting the value of money, the element of the array, into the target, and we are finding the upper bound of it, upper bound of the fruit array from starting from beginning to the end. But what we are doing next, that as we know that the return type of the upper bound is iterative, so we have to convert that into an integer return type. So for that we are removing the first integer, the first, that is fruit.begin, and after that we are getting the solution of the problem. So let's run this code and see if it's work. uh, First test case is running, and let's submit this code. So yes, we are submit. So this code is all the test cases are passed. So by this we have completed the third question of Shastra Challenge 3 Contest A, that is the maximum fruits 1. The source code for this question is available in Python, Java in the description below. If you find this video helpful, then please like and subscribe and follow TCD Shastra Coding Club on Instagram. Thank you for watching.